Japan is a great tectonic laboratory, a prime place for geologists to find out how the Earth works. We can look at how new continental crust is formed, and it's all to do with subduction. But curiously, this tectonic process destroys ocean floor by recycling it back into the mantle. We'll have a look at this, and we'll also see how the process of subduction creates the world's most powerful earthquakes. And we'll start briefly with volcanoes. How could we not? Japan and its region has lots of volcanoes, part of the so-called Ring of Fire. The volcanoes lie in linear belts, volcanic arcs, that follow alongside major oceanic trenches, deep furrows on the seabed. These trenches are plate boundaries, and these are the plates. These particular boundaries are where plates converge at pretty significant rates. And to see how this works, let's take a side-on view onto and beneath the island of Honshu and fill in below to show the floor of the Pacific Ocean being taken down beneath Honshu. This is the tectonic process of subduction. As the downgoing plate or slab sinks, it gives off volatiles, water locked into the rocks and sediments of the old seabed, usually at a depth of around 150 kilometers. And this water reacts with the mantle above, causing the mantle to melt, or at least some of it. It's this melt, the magma, that erupts at the Earth's surface to make volcanoes. But actually, most of the magma remains at depth, solidifying to make new continental crust. So subduction zones are factories of continental crust. Many geologists believe that almost all the continental crust has formed in this way over billions of years, and many now extinct subduction zones. So how do we know that subduction is happening? Earthquakes, color-coded for depth, they reveal the downgoing slab of Pacific plate with its veneer of oceanic crust. But if we're talking earthquakes, we'll need to go back to the 11th of March 2011 and the world's largest ever recorded earthquake. Over the course of around 3 minutes, this is how the earthquake played out. And it wasn't a single bang. After a few pre-shocks, the big one, at magnitude over 9, was accompanied by dozens of smaller but still large quakes. Then a cluster of others. Earthquakes come in swarms. So here's how the seabed deformed. It moved up to 50 meters eastwards towards the Pacific. Look at that scale bar. That's a patch over 300 kilometers long that's moved. And because the seabed is instrumented, geophysicists could see how quickly the rupture grew. The fault surface beneath the slip patch grew this big in under 3 minutes. The fault grew at over 1 kilometer a second. That's over 3 times faster than the speed of sound in air. Parts of the seabed went up, others went down. So we can use this information to understand what happened. Here's a cartoon with a subduction zone, and for a time it sticks, building up elastic energy, which is released in the earthquake, driving the seabed forwards, some up, some down. It's what geologists call a megathrust earthquake. And because it was huge and underwater, just like slopping about in a bath, the fault slip set off a tsunami, which has been modelled by the US National Oceanic and Atmospheric Administration as it radiated out across the Pacific Ocean. Eventually, a 2-meter high wave crashed into the Chilean coast some 24 hours later. And remarkably, a reflection of this wave from South America was recorded back in Japan some 48 hours after the original earthquake. But of course, the greatest tsunami effects were felt in Japan straight after the earthquake. Some 50 minutes after the shock, a 6-meter tsunami hit the coast, with run-up heights of up to 40 meters in places. In the front line was Fukushima nuclear power plant. Inundated, its power systems for cooling the reactors were knocked out, and subsequent fires led to one of the world's worst nuclear accidents. The combined effects of the earthquake, followed by the tsunami, and the lack of preparedness at Fukushima had global impacts. Many countries moved away entirely from nuclear power production, impacts that continue to be felt today as these countries endeavour to meet net zero targets. But beyond these impacts, the Pacific is well tooled with tsunami warning posts. Populations can move out of the way. Infrastructure is less mobile. And megathrust earthquakes are not unusual, although fortunately very few generate devastating tsunamis. Subduction then is a process that has profound impacts on humanity, not just around the Ring of Fire, but around the world. I've been Rob Butler. Thank you for watching this latest instalment of Ring of Fire, Tectonic Journeys in East Asia.